second day of factoring reviews, so we're going to go through a couple more techniques. So last time we did just factor out a GCF, factor by grouping when there's 4 terms, and then factor a trinomial when a is 1. So now we're going to be doing some trinomials when a is not 1. So there's actually 2 different strategies. This is my personal favorite. It's called reduce and bottoms up. So I'm going to use this strategy on these first 2. And then I'm going to show you, we can actually use factor by grouping as well. And I'm going to show you on those 2. So let's go ahead and dive in. All right, so reduce and bottoms up says we're going to multiply a times c. So again, when we are talking these a, b's, and c's, we're talking about this. So a is the number in front of x squared, c is the constant without a variable. So if I do a times c, I'm going to get 30. So I'm going to rewrite it as a trinomial when a is 1. And then I'm going to factor normally like I did yesterday. I'm looking for numbers that multiply to be 30 and add up to be 11. So numbers that multiply to be 30 that add to be 11 would be 5 and 6. Okay, so now it says divide values by LC. What this stands for is the leading coefficient. So my leading coefficient was 15. So I'm going to come through and divide by 15. Okay, now as you guys might recognize, whenever I have factors, I don't have fractions involved. They're all integer answers. So we're going to do this strategy, which is called reduce and bottoms up. So I'm going to reduce these fractions. So 5 over 15 reduces to a third. 6 over 15, I can divide both those by 3, so I get 2/5. All right, and then after I've reduced, I bottoms up. The denominator goes in front to be the leading coefficient, so this turns into 3x plus 1 and 5x plus 2. And that is factored. Again, I could check it if I distribute 3x times 5x, 3x times 2, 1 times 5x, 1 times 2, I would end up back here. Okay, all right, let's try that strategy one more time on this one. So multiply a times c, 9 times 4 is 36. So I've got this trinomial, factor normally, numbers that multiply to be 36 that add up to be 15, 12, and 3. Okay, now come through and divide by the leading coefficient, so divide by 9. Okay, reduce, so we get x plus 4/3, x plus 1/3, and then bottoms up. So that 3 is going to go in front, so we've got 3x plus 4 and 3x plus 1. Okay, so that is the reduce and bottoms up strategy. Again, this works for trinomials when a is not 1. Okay, now I'm going to show you the grouping strategy. This is, well, you guys can use whichever one you like more. They both work, they both get the same answer. It's just 2 different ways to do it. Okay, so factor by grouping. So this is a strategy we already know how to do. We just have to get it to be 4 terms. So how we do that is we actually do the same first step. I'm doing 15 times 6. Oh, actually, this is a good opportunity to see this. Right here, you guys, I actually notice all of those are divisible by 3. So I'm actually going to take out a 3 first, and I'm going to rewrite it as 3 times 5x squared minus 9x minus 6. Okay, so I'm going to leave this 3 out front, and I'm just going to focus on factoring what's in here. So this says multiply a times c. So 5 times 6, negative 6 is negative 30. So I want numbers that multiply to be negative 30 that add up to be negative 9. So let's see, we've got 15 and 2, 5 and 10, 5 and 6, 3 and 10. Oh, did I do, yeah. What else we got there? 2 and 15, I did that already. I think that's all of them. Oh, I know why, because I didn't change that to a 2. So 5 times 2 is negative 10. No wonder I couldn't come up with factors. All right, 5 times negative 2 is negative 10. So I have numbers that multiply to be negative 10 that add up to negative 9. So what I do instead of factoring like we did with reducing bottoms up is I just rewrite this 5x squared. The numbers that multiply to be -9 that add up to be -10 are -10 and +1. So what I do is I take those two numbers I came up with and I just split -9x into that. So now this is factor by grouping. Do 2 at a time, okay? So I can take out a 5x out of here, and I've got x minus 2. I really can't take anything out of there except a 1. But again, my goal is to get those to match, so I can go one more step. And then this 3 comes in front that I took out from the very beginning. So this would be totally factored. Okay, this one, I also noticed I have a GCF of 2 that I could take out of everything. So I've got 2x squared minus, oh, no I can't, never mind. 2 doesn't go into 21. All right, so we're gonna jump right into this strategy. So 2 times 40 is 80. So we're looking for numbers that multiply to be positive 80 that add up to be -21, and that's gonna be -16 and -5. They multiply to be positive 80 and they add up to be -21. So I'm going to rewrite this expression as 4 terms. So we have 2x squared minus 16x minus 5x plus 40. And it doesn't matter which order I do this -16 and -5. You could flip-flop those. That does not matter. Okay, so now I have 4 terms. Factor by grouping. Can take out a 2x. I'm left with x minus 8. Can take out a -5, right? I'm taking out whatever sign is there. So then I'm left with also x minus 8. Those match. We got x minus 8 times 2x minus 5. And then we took out that, oh, no, we did not take out a 2. I tried to, and I cannot factor out a 2. So that would be completely factored. So 2 different strategies there. Factor by reduce and bottoms up. Factor by grouping, both of them are great strategies when I have a trinomial when a is not 1. Okay, next we have difference of squares. So this is if I have this form, something squared minus something else squared. This will always factor into the roots, one with addition and one with subtraction. Okay, so this will always be the form for difference of squares. So here's how I find it. I look at this term. Can I take the square root? Yes, it is 2x. I look at this term. Can I take the square root? Yes, it is 3y. So what I do is I rewrite that, those two roots, and one's addition, one's subtraction. Again, I could put subtraction, then addition, doesn't matter. So that is factored. Here, okay, look at these two terms. Okay, what's the square root of 4? 2. What's the square root of 2a minus b squared? It's just 2a minus b. Okay, so I rewrite that, 2, and then 2a minus b. And then one's addition, one is subtraction. Okay, all right, can I take the square root of these? Is it subtraction? Yes, square root of x to the 4th is x squared. Square root of y to the 6th is y cubed. 2 of those. One's addition, one's subtraction. Okay? Can I take the square root of these? Yes, this is 4x and 7, but it's not subtraction, so this is what we would call prime. It is not factorable. Okay? I think I have one more. Yep. Okay. So next, you guys, this is just a pattern. If you recognize this, this is a really helpful thing for you to use. This is called a perfect trinomial square. We're going to get into a skill called completing the square where we're going to use this. But basically, if I were to distribute this out, so remember this means x plus 6 times x plus 6. So if I distribute that out, I get x squared plus 6x plus 6x plus 6 times 6, 36. So what happens is it's always this number squared as c, and 2 of this number for b. So it's going to turn into x squared plus 12x plus 36. So it's kind of a pattern that happens whenever I do something times itself as a binomial. This one's the same thing. So it's going to be x squared, 2 of those with x and then that squared is a positive 9. So it just saves you some time. So if I recognize something that has that pattern, I know that it factors. This would be x plus, or sorry, not x, in this case, a. This would be a plus b squared. This would be a minus b squared. So if I recognize that, that is helpful. So like this one, that's 3 squared, that's 2 times 3. So this came from y plus 3 squared. This one is 7 squared, or negative 7 squared. This is 2 times negative 7, so this came from x minus 7 squared. So it just saves me a little time. I could still do the method of what multiplies to be 49, that adds to be negative 14. I could still do that and get the same thing. This is just a shortcut. Okay, numbers, that's 4 squared, that's 2 times 4, but this has an x to the fourth and x squared, so instead of just x, it's going to be x squared. And then I have 4. Okay. Here, okay, so this is 3b squared, and that's 2. Oh, and actually in this one, you guys, I do want to take, okay, so here's another part of the pattern we can look at. This part came from here, so this is the square root of that. So if I look at the square root of that, it's 2a. So that's going to be 2a minus whatever the root of this is, which is 3b squared. And so basically what happens is it's these multiplied together times 2 to get that middle term. Okay? So again, this is just a perfect trinomial square. It's a shortcut. You could do it the same way we were doing a times c, or just looking for numbers that multiply to bc that add up to bb. Those will work as well. Okay, this is the last part of this video, and this is probably new for you. This is kind of like difference of squares. It is 2 things I can take the cube root of, and it always factors the same way. Minus ab. All right, so if it's addition between, this is what it factors to be. If it's subtraction in between, it factors to be this. Looks super similar, just a couple of the signs are flipped. Okay, so the biggest thing to be able to do sum of difference of cubes is look at, are there 2 terms? Are they things I can take the cube root of? This is yes. So using this form, a is x for me. Here, b is 2, right? X cubed, 2 cubed is 8. So it's using this format. So I'm going to plug in x for every single a and 2 for every single b. So we've got x minus 2 times x squared plus 2x. And then 2 squared is, sorry, that's not supposed to look like that, b squared. There we go. And then that is factored. I could check this, but it's never going to factor for their numbers that multiplied to be 4 that add to be 2. There are no real numbers that do that for us. So that is our factor. Okay, this one, same thing. Can I take the cube root of this? I can. It's 3x. That's the a. Cube root of 1 is just 1. Okay, this has addition between, so it's going to follow this format. So I've got 3x plus 1. 3x squared is 9x squared. Minus a times b, so 3x times 1 is 3x, plus b squared, which is 1 squared, so that would be our factor. Okay, that's all for day 2 factoring review.